This conference will now be recorded.
Very good evening, students.
This conference will now be recorded.
Very good evening, students. We have still few questions remaining from the previous year's JEE Main paper. Excuse me. Held on 5th September 2020. So today we have few questions to discuss. Let us start our discussions. So this type of question is very important. This is from actually wave motion. Okay, this question you see here is from wave motion, and this type of question is very important. Okay, this in this current year, this particular question will be asked in the experimental skill section. So in a resonance tube experiment, when a tube is filled with water up to 17 centimeter, up to a height 17 centimeter from the bottom, it resonates with a given tuning fork. When the water level is raised, the next resonance of the same tuning fork occurs at height this much, 24.5 centimeter. If the velocity of the sound in air is 330 meter per second, the tuning fork frequency is. So you look, suppose this is a resonance tube. What is done, there will be a water filled in it. Okay, water filled in it initially. Suppose actually what happens, so there will be arrangement to fill water externally from the tap into this tube, and you will be given a tuning fork, and that tuning fork you have to ring once, okay, so that you produce a sound from tuning fork and bring near the tube, and you have to look for the resonance to occur, or the highest intensity of sound you should hear. Okay, a highest frequency of sound you should hear. Okay, that is the resonance. So suppose you want to measure this tuning fork is given to you, but its frequency is unknown. So how to find out frequency of this unknown tuning fork? Using this resonance tube experiment. As you know, resonance means what? If suppose this resonance tube is filled up to certain height, suppose this has length, the total length L, say, okay, it has total length L. Okay, but now I'm sorry, now when you produce sound from this tuning fork and bring near the tube, and you are changing the height of the water, you could see that there is resonance, and the first resonance, you can say resonance at some L1, small L1 length, okay, from the bottom. Okay, when The height of this water level is small L1. You can hear the resonance. Resonance means what? At this particular length, the frequency of this closed pipe is exactly equal to the frequency of the tuning fork. Okay. So if you know that this is the first resonance, then you would have written lambda by 4. First resonance is this one, right? Okay, first resonance lambda by 4, L by, see this L1 then will be equal to lambda by 4. But anyway, it is not written that it is first resonance. Then what we should take? We should take the general formula. Okay, we should take the general formula, that is L1 is equal to, suppose, n lambda by 2 plus lambda by 4. Okay, this corresponds to this L1 length. Now I can directly put the length. See, from here I don't know the order, right? If I would have known the order, then I could write, see, I could write the length from the measurement. Okay, and I would have, see, found lambda from here, and then mu is equal to v by lambda. That I would have done if the order had been given, but the order is not given. So that's why we have to take another reading. Okay, another reading, and that reading must be the next frequency. Okay, that must be that must be the next harmonics. Okay, harmonics I should not say, the next resonance, next order. Okay, you have, say, okay, let me tell you. So if this is the first order, or the fundamental mode, then you should have got in this closed pipe the next mode. Okay, next mode. Okay, fundamental, then first order, second order, like that. So I should have got the next mode. Okay, next mode of vibration of the air column. So I suppose it has been elevated. See, the water level now at L2, when I get another resonance with this, okay, with this tuning fork. Okay, then I can write this L2 as L higher order, say. So this divided by lambda by 2 plus lambda by 4. This is actually, that means if this is first order lambda by 4, then the other one will be 3 lambda by 4. Like that it comes, right, in the closed organ pipe, isn't it? So that is what I am doing here. Now look, I have L2 and L1 given in this case also. So first resonance was seen at 17 centimeters. That means this is equal to 17 centimeters. Okay, and then L2 is given as 24.5 centimeters. Okay, so from here, actually, if we subtract, see, if we subtract L2 minus L1, if I do, then I get, see, then what I'll get, this minus this. So lambda by 4 anyway will go. So I'll get lambda by 2, that is equal to L2 minus L1. Okay, and that is equal to 24.5 minus 17 centimeter, which is actually 7.5 centimeter. Okay, 7.5 centimeter. All right. So what is lambda? So what we have got then? So I hope you are understanding what I have done here. If the order had been given in the first case itself, if we knew the order, then I can directly write the relation between the length and the wavelength, but that is not given. See, order of the vibration or order of the mode is not given. So that's why I'm taking the general mode. Okay, the mode, like mode and the next mode. Okay, this is n lambda by 2 lambda by 4. So this is the fundamental mode lambda by 4, along with that some mode, and just next mode. Okay, n plus 1 lambda by 2, the next mode I have taken. So then I had just subtracted. So from here I had got lambda by 2 is equal to 7.5. So from here I get lambda is equal to 15. This is in centimeter. Okay, so once I get centimeter, say this wavelength, I can get the frequency of the sound in the air. Frequency of the sound in the air is velocity of the sound in air divided by lambda, v by lambda. And see, v is given as 330 meter per second. So I have to make this lambda also into meter, 10 to the power minus 2 here. So this will give you actually hertz. Okay, per second. Okay, so let me just see. This is into 100 divided by 15. So this will give you, this is the one. Okay, so look here, the option D will be the correct answer in this case. I hope guys you have understood this. So I am not repeating. All right, so let us go to the next problem. So now this onwards, this problem onwards, we have section B. Okay, so in the section B, what you have numerical type problem. So you have to have answer in numerics. Okay, number, some number, and here there will be no options. There will be dashed here, or fill in the blanks type problem. Okay, so the first problem says a particle of mass 200 MeV by c square, this is the unit of mass in high energy physics, collides with a hydrogen atom at rest. Okay, there was hydrogen atom at rest. Okay, and a particle comes and hit it. A particle comes and hit. Particle has mass, let us say this is having mass small m, this has mass capital M. Soon after the collision, the particle comes to rest. Okay, so after collision, so this collision happens. Okay, and then what happens? Particle come to rest, but this hydrogen atom will have certain velocity. Okay, suppose, okay, come to rest, and the atom actually recoils with the velocity. Okay, recoils means it actually attains some certain velocity and goes to its first excited states. Initial kinetic energy of the particle in eV, electron volt, is n by 4. Then the value of n, where, so you have to find out what is the value of n here. Given mass of the hydrogen mass is given 1 giga electron volt per second square. So what happens? The particle comes with certain velocity. Okay, that is not known to us, which we have to calculate. So it has certain kinetic energy, it is said, and when comes with kinetic energy and hit the hydrogen atom, since it is actually massive, the hydrogen atom is massive than or larger in mass than this particle, because the particle has mass. So let me write this as m. M has mass, how much? M 200 MeV by c square. That means what? In electron volt, you will get 200 into 10 to the power 6 EV by c square. Okay, so which means, you know, this is 10 to the power 2 into 10 to the power 8 eV by c square. Okay. What about mass of hydrogen atom? That is 1 GeV, giga electron volt per square, which is actually 10 to the power 9 eV by c square. Okay. So if you compare with this, then you look, it is actually, so M is 5 times of small m. This we can see easily. Okay. That's why, since this is very large in mass, 5 times, okay, compared to this, so obviously we will be taking this as elastic collision, and after the collision what happens, the particle remains at rest. Suppose initial velocity some vi, and this has got zero velocity after the collision, but this hydrogen atom, it has got certain velocity, let us say, that is vf. Okay, va. And not only that, it is, this hydrogen atom actually goes to its excited state. That means some energy has been taken to change its state also. So I can write actually from law of conservation of linear momentum. I can write initial momentum was mvi plus 0 is equal to 0 plus mvf. Vf is the velocity of the hydrogen, final velocity. Okay, so what we get here, this small sorry, yes, small m by capital M into vi. That means what? M by M means what? So from here we get small m by capital M is 1 over 5. That means vi by 5. So we can get the final velocity, or the velocity with which the hydrogen atom recoils. Okay. So this recoil energy, I can write half m vf square, right, and plus the energy of the second excited state, the energy gap between, so it is actually, it is going to see the hydrogen actually goes to first excited state. Okay, so first excited state, that means you have to find out the energy difference. Okay, so that energy difference will be added with this, so this will be actually is equal to the half m v initial square. Okay, so this is actually the formula. This is energy conservation. So from energy conservation we can write this energy conservation. Okay, from energy conservation. So let us see this. We will write this from energy conservation. We get half small m vi square. This is equal to half capital M vf square plus delta E. That is change in the, say, ground state. You know, hydrogen energy has, and hydrogen has energy minus 13.6. Okay, so in general En will be by n square. So E2 will be how much? 13.6 by 4. So this will give you actually 3.4. So this 3.4. So I have to find out, say, E1 is again, E1 is 13.6. Okay, I will get actually mod of this, otherwise there will be minus sign over here, bound state. Okay, so E2, see delta E modulus will be 13.6 electron volt minus 3.4 electron volt. Okay, this will give you 10.2 electron volt. Okay, this is 10.2 electron volt. All right, so now I'll put this value. Mass is given 10 to the power 9. Okay, and this is v by c square, and this velocity in terms of, that is this vi by 5, vi by 5 whole square is equal to, oh, sorry, plus delta E. This I can directly write 10.2 ev. This also will come in ev anyway. So look here, I have this also. This I can, better to have this, let me write this as m itself, capital M, because I have a relation here. So I have vi square, I'll keep it like this. So half m vi square, I'll keep like this. If I bring here 1 minus, this is 5 m, I have taken common, so 5 divided by 25. Okay, this is 1 over 5, right? So this will be 10.2. I don't know, maybe I'm making it too messy, but still, let me check once again. So this is the kinetic energy which I have to find out. Into this is 20 by 25, 10.2 ev. So this is actually k is equal to 25 by 20 into 10.2 ev. Okay, so I hope things will be all right. 5 here, 4 here. Okay, so somehow, okay, let me check what is the problem here. Okay, 5 by 5, this is all right. Capital M is 5 into M, that is fine. Here, this is fine. Half mv squared, so this I have brought this side, so there will be 5 m I have taken out. This is all right. 25, so 20 by, okay, okay, all right, I think we are done. Yes, so this will be this, and in the question, what is given? The initial kinetic energy of the particle is n by 4, n by 4. So you have to find out the value of the n. So we are here, see, n by 4. So what is the value of n? N is actually 51. Okay, so n is 51. Look, n is 51. Okay, all right. Now let us go to the next problem. Here, a force F is given I cap plus 2 j cap plus 3 k cap Newton x at a point this, then the magnitude of the torque about a point this. Okay. All right. Let us try to. I think this is three-dimensional. We cannot locate it, but still, what we can have. Suppose the force is acting like this. Okay. This at some certain point here. Okay. Now I have to find out the torque from certain point like this. About this point I have to find the torque. That means you know what you have to find out. You have to find out the r vector. So this is point, say this point is say 4 I cap plus 3 j cap minus k cap. Okay, about this point I think I have to go like this. Okay, at this point, okay, I have to find the torque at this point, about this point. Okay, this is the point here. All right, sorry, this point should go like this. Like this. Okay, this is the point. About this point I have to find out the torque, 2j plus k cap. Okay, so I have to find out the r vector actually. Okay, because we know the torque, say this way the force is acting, so torque will be r cross f. So here the point is, what is r? F is given, so r is actually minus k cap minus of this point. Okay, because I am finding out the position vector. Okay, so you will get actually 3 I cap plus j cap minus 2 k cap. This is the position vector r. Now it is, now life is easy, right? So let us take this space. Okay, I don't have space over there, so let me write it directly here. The required torque is, or the torque we obtain is r cross f. R is 3 I cap plus j cap minus 2 k cap cross f. F is I cap plus 2 j cap plus 3 k cap. So this cross product, since it is three-dimensional, better to use the, this is magnitude. I think you have to find out the magnitude. Okay, so first you have to do the cross product. So ijk, do in terms of this determinant method, so that you will get this easily. I cap is equal to 3 plus 4 minus j cap 9 minus plus 2 and then plus k cap, which is 6 minus 1. Okay, so what is the torque you get? You get 7 I cap minus 11 j cap plus 5 k cap. Now you have to actually get the mod of that. So mod of that will be square root of 79 plus 1 to 1 plus 25. So you have to get the value. So 1 to 1 plus 4 9 plus 2 5. So 5, the choice. So this 6 to 8 19. So 195, square root of 195. So this is the value. So x has got value 195. So this is the answer. Okay. Now let us go to the next problem. This problem says two concentric circular coils C1 and C2. This is actually from electromagnetic induction Faraday's experiment. C1 and C2 are placed in the XY plane. So these are two coils. Okay. Okay. These are two coils. I think both of them will be given the, okay, for both of them the number of turns and radius are given. See, radii are given. C1 has, so suppose this is C1, this is C2. C1 has 500 turns. Okay, 500 turns. Capital N1 is equal to this, and it has got radius. Okay, R1 to be 1 centimeter, and then C2 has got turns. C2 has got turns 200. This is N2, I should write, and it has got radius 20 centimeter, bigger one. C2 carries a time independent, so it is actually carrying a current which is a function of time, and that current is given actually I2t is equal to 5t square minus 2t plus the I2t means this current which is flowing through the coil C2. Okay, so EMF induced in one. So you know that if the current changes in the second coil, if this coil, these two coils are placed side by side, when flux changes in this, there will be induced EMF in the second coil. Or in other words, if there is a change in the current here, there will be flux change in the second coil. Change in the current means there will be change in the flux here, so that flux, the flux linked with this coil C1 also will be changing, right? So I have to find out here EMF induced. EMF means what? I have to find out EMF in this, that is minus, or if I take the modulus for the time being, so I get d phi 1 by dt. Okay, so this is what we have to find out here. See, what is phi 1 then? How to find out phi 1? Phi 1 will be, see, the flux linked with this. Okay, phi 1 flux linked with the coil of 1. That means, you know, the current magnetic field in the produced by the coil 2 and area of the coil of 1 and the number of turns in the coil of 1. This will be the magnetic flux linked to this. Okay, now let us see. So di dt, what is this di dt? Okay, this di dt is actually, this is 10t minus 2. At t is equal to 1, it is, see, at t is equal to 1, I have to find out what is the value of EMF. Okay, at t is equal to 1 second, what we get di dt? We get di dt to be equal to 8 ampere. Okay, ampere per second. Okay, this is given. So now with this we will go with, but what is this B? B2. B2 is the magnetic field. We will write magnetic field produced at the center. What is the magnetic field produced at the center of this? Okay. So magnetic field produced at the center is actually mu0 into I. Actually, this will be small n. I'll write it what it is. Small n2 I by 2r. Okay, this is length, turns per unit length. Okay, turns per unit length. Okay, turns per unit length. So this I can further write mu 0, this is R2, mu 0 n2 means actually n2 I divided by 2 R2 into, this will be multiplied with, okay, so I have to actually divide 2 pi R2 again. Okay, this will be actually the magnetic field. Okay, mu 0 Ni by 2 R. All right, so I have been given all the parameters here. Let us go for the exact solution. Let me get the options, sorry, this informations. So the question was, two concentric circular coils C1 and C2 are placed in the XY plane. So let me go to the next page. So I'll have this expression mu 0 into I. I have to first find out B2, isn't it? Mu 0 into I divided by 4 pi R square. Okay, this is R2 square. Then I have to find out what is EMF, right? Phi 1 is actually, phi 1 is B2 N1 A1. Let me write this. B2 is this, N2I divided by 4 pi R2 square, then N1, okay, N1, and A1 is actually pi R1 square, okay. So I can strike this pi's, okay, if required. 1 pi still will come from this mu. I would have read, let me keep this pi actually. This will help me to do the calculation easily. Okay, let me just do the calculation there. Mu 0 by 4 pi is 10 to the power minus 7. N2 is given 500. I'm sorry, this N2 is actually 200. Sorry. N2 is 200. 200. Then N1 is 500. This value I have already written. And pi, let me keep this. This R1 is 1 centimeter. So if I take this 1 over 20 centimeter, 20 whole square, okay, then there is no harm. Centimeter will cancel each other. Now I have to find out E1, mod of that is d phi 1 dt. So all the factors in this factor will be constant, so no need to worry. So this will be 10, so 10 to the power 5 pi. This I can write 400, and this is di dt. Di dt, look in the first page. So here we have found out that is 8 ampere per second, right? So I'll write it here 8 ampere per second. Now my things are all right. So I can actually find out the answer for this then. So you'll have here 10 to the power minus 2. This will come up. So 10 to the power minus 4 divided by this will go to this. I have already done the calculation. This also is done. So I am actually getting 2 pi into 10 to the power minus 4. I have to check x 4 by x. Okay, I have to write 4 by x, right? Okay, so 4, let me do one thing, 4 into 2 pi by 4 into 10 to the power 4. Okay, I have in milli, okay, milli, okay, in terms of millivolt, right? 10 to the power minus 3 I'll keep there, and 110 I'll bring down. So this is now I get, this is 20. So I get 4 by 4 into pi by 20. Okay, like this I'm getting. Okay, I'll write it clearly. So what I get is 4 into pi by 20. So kind of this I'm getting. Okay, let me cross check whether I have done some mistake. I think is everything okay? Just a minute. It is coming around 4 by 6 approximately. So I actually there may be some small typo somewhere, but this is the procedure anyway. I'm not repeating, the answer will be actually 5. Okay, so dear students, I'll actually request you to do and see whether you are getting 5 or not. I don't know, maybe somewhere some small typo I have made, or I forgot to multiply something, or okay. So I think this is the procedure overall. So you have to go and do it. This is actually 5. The answer is 5. Okay, so all right, let us go to the next problem. Okay, so this problem, let me write the statement of the problem. A compound microscope consists of an objective lens, of focal length 1 centimeter, and an eyepiece an eyepiece of focal length 5 centimeter with the separation 10 centimeter. With the separation 10 centimeter, then the question is this: the distance between an object an object and the objective length at which the strain in the eye is minimum. Strain in the eye is minimum. Is n by 40 centimeter. The value of n is n is this. Okay, this is the question. So look here, compound microscope has two lenses. One is objective, which is actually near the object, and the eyepiece through which we see, okay, where our eye will be. Okay, so that is the place of the eyepiece. Now look, this compound microscope or telescope, whatever you say, wherever there are two lenses. This they can be used for two different settings. One setting is called normal setting. That means final image is formed at infinity. Final image is formed at infinity. Okay, at infinity. Okay, another setting is image formed at least distance of distinct vision, that is D, right? Least distance of distinct vision, that is D, which is 25 centimeter. So these are 25 centimeter, least distance of distinct vision. So these are two different settings. So among these two, when you see an object formed at infinity, that time the eye will be more relaxed, and this is actually having very less or minimum strain to see anything. Whereas when you see some object at 25 centimeter, our eye gets strained. Okay, so that means with this eyepiece we should have image formed by eyepiece at infinity. So that is the condition. Here it is said the distance between objective and object at which the strain in the eye is minimum, that we have to find out. And that is possible only when, suppose this is the middle point 5 centimeter. So this is 5 centimeters, say. This is focal length of the eyepiece. Okay. So the image formed by the objective must be falling on this. Okay. So what is the idea here? We have to have image formed by this objective must be at 5 centimeter, and for that we have to keep the object at certain distance, which you have to find out. Whereas focal length of this objective length is given. So my final image has to be formed at infinity, and for that the image formed by the objective has to be at exactly at the focus of the eyepiece, so that the image formed by this eyepiece will be at infinity. So this is the idea. So now look, we have got V for objective lens. We have got this B is equal to 5 centimeter. F O we know that is 1 centimeter. Then it is easy now, right? 1 by V minus 1 by U is equal to 1 by F, right? So V is positive anyway. U I have to take as it is. So 1 by F. F is also positive for this. So I have got then 1 by U is equal to 1 by 5 minus 1. So that will be minus 4 by 5. Okay, minus 4 by 5. That means U will be minus 5 by 4 centimeter. Okay, this sign is saying that your object will be on the left hand side. So what is the answer? So here in the problem it is said the minimum distance will be n by 40, right? N by 40 centimeter. Look, the distance would be n by 40 centimeter, that is given. Okay, now we have got 5 by 4 centimeter. So what I have to do, I have to multiply 10, so 50 by 40 centimeter. So n is 50. Okay, so n is actually 50. If we compare these two, then we get n is equal to 50. So we have to keep the object at 50 centimeter away from the lens. Okay, the objective lens, so that we can have an image, final image at infinity, where the strain will be minimum. So for today, I think this is all for today. In the next class, we'll complete the 2020 JEE main paper, September 5th, and then we'll take up further 22 and 23, 21, etc. Okay. After 20, I'll take 22, because this is 24 is the even year, so there will be more chances of having similar type of questions. Okay. All right. So thank you for your questions. Bye for today.